Heyo, welcome back everybody. This will be the last installment of the Exponent Laws series. This one is another product property, which means we're dealing with multiplication, but in this case, instead of the base being the same, it's the exponents that's the same. So the product property states when multiplying expressions with the same exponent, you can keep the exponent or leave it the same and multiply the base numbers. So here's your example. Notice that the exponents are the same, but the bases aren't. So we take 5 times 6 and we get 30. We leave the exponent the same, and that is our final answer. Earlier in the year, we did this in class, and we proved why it works. In this video, we won't be talking about why it works, just how it works. So let's start taking a look at some of these examples in green, in which, again, we're talking about a product, which means multiplication is involved, but in this case, the exponents are the same. So we multiply the bases, 2 times 4, we get 8, we leave the exponent of 5, and we get 8 to the 5th power. In our next example, we're going to see that the exponents are both 14. This means we can multiply 11 times 5, that's 55. Leave that now as our base, and the exponent remains the same. We leave that at 14, and our final answer, 55 to the 14th power. In our next one, notice again, exponents are the same, both 21. So we do 5 times 20, we get 100, and 100 to the 21st power would be the appropriate way to say that, and it would also be the right answer to this question. Now we have the same exponent of 3. 2 times 31 is 62. So we get 62, and we leave the exponent the same. This is a shortcut that allows us to evaluate exponents or expressions with exponents as long as the exponents are the same. In this example, some of you might be thinking to yourself, well, I could actually use same base. You could. Okay, we can multiply the bases and get 49 to the 7th if you wanted to. You could add the exponents and leave the base and get 7 to the 14th. That would be the same value. In this one, we have a variable, but the exponent is the same. So all we have to do is 2 times 6. That's 12. What does the b stand for? In this case, all we know is it's a placeholder, so we're going to leave it there, and 12 to the b power is our answer for that one. Now we have a negative exponent here. This does not change anything because the exponents are the same. So we're just doing 8 times 4. That's 32. There's no reason to change. The rule says to keep the exponent, so we're going to keep it. 32 to the negative 12th power. Here come the red slides, so you know sign numbers are involved. In this one, negative 3, exponents are the same, but what's 10 times negative 4? It's negative 40. Sign number rules say that when the signs are different and multiplying, the answer is always going to be a negative. Another red one. In here, we have the same exponent, both 15, and the bases are both negative. So we multiply the bases, negative 5 times negative 6. When you multiply and the signs are the same, the answer is always positive. So we get positive 30, and we leave the exponent of 15. Here we just have negative exponents. Doesn't matter, the exponents are the same. We just have to do 13 times 14, which is 182. And for some reason, the exponents got added there. That is weird and completely wrong. God effing. Okay, so ignore that last example. It was wrong. I'm too lazy to go back in and change it, so let's just leave it at that. All right, here we have another example. Exponents are the same, so we leave it. Negative 9 times negative 6 is positive 54 because the rule is when the signs are the same and you're multiplying, the answer is a positive. So here we have an interesting problem. We didn't learn anything about a quotient property when the exponents are the same, but it does work the same as the product property, and you just divide the bases. So let's take a look here finally at how this property works. Okay, if there is a multiplication problem in which the exponents are the same, we're going to keep the exponent the same, and we're going to multiply the base numbers. If you look here at all the examples I have, this is done in all the examples. For those of you that were making some mistakes with sign numbers, Carlos, let's try to make sure that either you're remembering the sign number rules or using a calculator to check your work. Super important. Okay, So any problems with this, you're going to always be free to send me messages on Google Classroom or Pupil Path. Feel free to reach out to all 942 paras that are assisting us here in our mission to teach you guys 8th grade math. Good luck.